In this video, we're going to take a look at finding the sample standard deviation of a raw set of data. Now remember, to obtain a sample standard deviation, we must first obtain the sample variance, then just simply take the square root of that to obtain the sample standard deviation. Now remember what a sample variance is. A variance of a set of data is just the measure of spread from the sample mean, or the center of the distribution. There's two methods that you can follow to find the sample variance. One method is to find the sample mean and subtract the sample mean from each individual data point, then square those values and divide by n-1. Another method would be to find the sum of your values as well as the sum of your squared values and follow the formula for variance that way as well. Now go ahead and pause the video and try this example on your own. Okay, I'm going to show you both methods in finding the sample variance. The first method here is what I first explained by finding the mean and subtracting it from every single data point, squaring them, adding them all up, and dividing by n-1. First, we would have to obtain the sample mean. Now in order to obtain the sample mean, all we have to do is add from I equals 1 to n, which just simply means from the first data point all the way to the nth data point, in this case the 5th data point, and we would divide all of that by n, however many data points you have. So in this case, we're going to add from the first data point, so I equals 1, all the way to the 5th data point, and we're going to divide all of that by 5 because there's 5 data points. In this case, we would have 13 plus 1 plus 7.5 plus 3 plus 21.2 all divided by 5. This gives us an answer of 9.14. So that's our sample mean. Now what we would have to do is take this sample mean here and subtract it from every single data point here, then square each of those, add them all up, and divide by n-1. The simplest way to do this would be to create a little chart for yourself. So what I'm going to do here is create a chart showing every single data point, so the first one being 13, minus the mean of 9.14, and we need to square that, which gives us 14.8996. Now you need to do this for every single data point because you need to add the resulting answers. So here we can easily find the variance, which is denoted by s squared, to be each of these values added up divided by n-1. So here this formula evaluates to 266.992 all divided by 4, which works out to a sample variance of 66.748. Now again, the sample variance is just simply the measure of spread from your sample mean. So the sample standard deviation would just simply be the square root of your sample variance, so the square root of 66.748. That works out to 8.1699, which gives us our sample standard deviation. So that there is our answer. Now that's one method for obtaining the sample standard deviation. Now an alternate method to finding the sample variance and sample standard deviation would be to find the sum of squares all divided by n-1. Now your sum of squares formula is equivalent to the sum from I equals 1 to n of all of your squared data points minus the sum from I equals 1 to n of all of your data points added up, then squared, divide that by n, and then divide all of this by n-1. This is just an alternate formula. Some may find this formula a little bit easier to use, especially if you know how to use your calculator. If you know how to input your data into your calculator, you can easily find this sum here as well as this sum here and then plug it into this formula. Now the difference between those two sums is the second one, the sum from I equals 1 to n, just simply means adding up all of your raw data, so 13 plus 1 plus 7.5 plus 3 plus 21.2, and this here would give us 45.7. Now the sum from I equals 1 to n of all of your values squared would be 13 squared plus 1 squared plus 7.5 squared plus 3 squared plus 21.2 squared. Now that would work out to 684.69. So in order to use this formula here, all we would do is plug in the sum from I equals 1 to n of x sub I squared would be this value right here, 684.69, minus that second sum would be the 45.7, but we would need to square that value. We divide all of this by the sample size of 5, and we divide all of that by n minus 1, which is 4. This here would work out to 66.748, which gives us our sample variance, which is the exact same answer as above, and therefore your sample standard deviation, again, is simply the square root of your sample variance, which is the square root of 66.748, which again gives us the same answer as above of 8.1699.